Let's talk about how we can denote a derivative, which means how can we write a derivative in different ways. Calculus likes to make things difficult for you by having different notations for the derivative. What have we seen before? Well, we've seen that if y equals f of x, then our derivative is f prime of x. But we've also seen that if we are given a function of y equals, the derivative is a y prime. And so this is how you would state it, y prime. Well, what do we think about that? It's nice and it's brief, but it does not name the independent variable. Notice how here we know that we're talking about an x in the function, and the derivative f prime of x says, hey, we're dealing with an x. And this is really important when we talk about our applications unit. So although the y prime is nice, and we'll certainly use it this year, it's a little simplified. All right, if you see this, this is a really fancy way of saying take the derivative. And we pronounce this as dy dx, or the derivative of y with respect to x, meaning we're taking the derivative of a y equals function, and the variable would be an x. You can sometimes see something like dy dz if you have a function like y equals 3z squared plus z plus 1, and you're taking the derivative of that. The derivative would be a dy dz. All right, so just keep that in mind. That's a fancy way of saying take the derivative. This is nice, again, because it names both the variables and uses d for the word derivative. All right, the next one is df dx. That's how we would pronounce it. It's the derivative of f with respect to x. And this is nice because it emphasizes the function's name. So let's say it's the function f of x equals x squared, and I ask you to do df dx. That means take the derivative of the function f, and that would be 2x. And we'll learn about why it's 2x later today. All right, the next one is d dx of f. I usually say of x, but the computer says at. So this is d dx of f of x. All right, so that is basically saying take the derivative of our function f of x. It's almost the same thing as this one, but they've taken the f and they've put it out here and said f of x. All right, so what's the good thing about this one? Well, it emphasizes the idea that the differentiation is an operation. It's like you're doing something to f of x, right? So that's why that one's good. You definitely need to know how to recognize all of these as basically saying take the derivative. All right, these are the 4 rules that we're going to learn about today, and you might want to take a second to again pause the video and take notes on this. Let's get into some more detail on each of these rules. The first is the constant rule. So here's our rule. It says if the function is a constant value, then the derivative of a constant c is 0. Why is that true? Why is the derivative of a constant 0? Well, let's just go ahead and let's graph a constant. For example, let's graph y equals -2. All right, that's this right here. Well, what is the slope of the tangent line for any point on that graph? Well, if you look at this point right here, our tangent line would be something like this, and that has a slope of 0. So for this entire page, you should note that we have constants, all right, and we're taking the derivative of each of these. And this rule states that our derivative, or the slope of the tangent line, is going to be 0. So for example 1, we've got y prime equals 0. For the next one, if we have f of x equals 12, we'll have f prime of x equals 0. For the next one, notice how this is y equals, and this is stating dy dx, which means that our variable is x in this and our function is y equals. And so this is saying, hey, what's the derivative? Well, we've got a constant, so the derivative of a constant is always 0. Here's another thing that you can see. We've got d dx, and then it has the function listed right there. That's an example of this one right here, where it's basically saying d dx, and then it's got your function listed inside. So that's an example of that one. Well, what is the derivative of negative 50? Again, that's going to be 0. So the constant rule is that the derivative of anything is 0. All right, let's go ahead and take a look at the power rule. This is the one that people start throwing things at me. They're like, hey, Ms. Sorensen, it took us 10 minutes to do each of these problems, and all we had to do was this. Yeah, that's true. However, on your final, you do have to do it the long way for the very first problem. So notice here that our rule is that if we have some sort of exponent going on, like x to the 7th, we would call that exponent n. All right, and if we're going to take the derivative of it, we take that n and we put it out in front. So here it is out in front, and then we subtract 1 from it. Let me see if we can do that with a concrete example. So here, y prime, because I've got y equals, I'm going to take that 4, put it out in front, and then what I do is I subtract 1 from the n. Well, it was a 4, subtracting 1, I get a 3. And that's it, you're done. All right, let's try example 2 here. Oops, that's the wrong notation. Notice that I've got an f of x, so this should be f prime of x. So here I'm going to take my negative 6, pull it down in front. So that'll be a negative 6 x. Now please be careful. What is a negative 6 minus 1? Well, that is a negative 7. That is a common mistake. People would usually write like minus 5 or something. That's not right. All right, this next one says y equals, and so dy dx is a good notation for saying, hey, take the derivative. But I'm actually going to rewrite this. If I've got y equals 1 over x to the 1/3, that's equivalent to saying x to the negative 1/3. Is it not? Because I'm just bringing it up to the numerator. So now let's go ahead and let's take the fact that we've got a function y equals x to the negative 1/3, and let's find the derivative. So dy dx says take the derivative. So we bring that negative 1/3 down in front. Then I write x. And now I need to subtract 1 from this. Well, what is a negative 1/3 minus 1? Well, to do that, we have to get common denominators. So this is going to be a minus 3 over 3. This is the same thing as saying minus 1. All right, so let's go ahead and subtract those. Well, we keep our denominators the same, and then we're simply just going to do the operation in the numerator, which is a negative 1 minus 3. Well, that is going to be a negative 4. Okay, so this is going to be to the negative 4/3 power. And we're done there. All right, next one is, how do I find the derivative of the square root of x? Well, we used to have to do this all with limits, and that was a long problem. But remember, we can rewrite this as our f of x equals x to the 1/2. So how would you take the derivative of this, or d dx? Well, we would take the 1/2 and bring it down in front. So we get 1/2 x. And then we have to remember to subtract 1. Well, that's subtracting 2 over 2. So 1/2 minus 2 over 2, again, keep the denominators the same, but what is a 1 minus 2? Oh, it's a negative 1/2. So this would be our answer here. And if you want to rewrite this, you certainly can. So rewriting this, this would be 1 over 2 the square root of x, because negative 1/2 goes to the denominator, and we know that to the 1/2 power is a square root. Okay, rule 3 is the constant multiple rule. This is basically saying Do the same exact thing that you've done before on the last slide, except if there's a number out in front, you need to multiply it when you bring that n value down. This is another way of saying, hey, just whatever the derivative is of u, you write the derivative of u down, and then just write the constant there as well. That sounds super confusing. Let's go ahead and tackle this. So here I got y prime, bring the 3 here, and now I have to do a -4 times 3, and that's going to be x to the, I've got to subtract 1 from here, that becomes a 2. So this is equal to -12x squared. Okay, this next one, f prime of x, I chose that because this is f of x. This is going to be a 30, because 6 times 5 is 30, and then x to the 5th. All right, this next one I'm going to rewrite on the side here as y equals 7 times x to the, well, what is this? The cube root of x to the 5th. Well, we're going to write that as, is it going to be 5/3 or 3/5? Well, it's going to be 5/3. And I think we called it dancing narwhals sometime. That goes to the denominator, that goes to the numerator. Dancing narwhals. All right, so now that we get that that's our y equals, we just have to go ahead and bring this out in front. So this becomes 7 times 5/3. And then x to the what? Well, we have to subtract 3 over 3. That's subtracting 1. So that's going to give me a 2/3. 5 minus 3 is 2. Okay, so let's just make sure we've got this in the best possible simple thing. So if I have that 7, I'm going to write it as 7 over 1. Now I got to multiply across when I'm multiplying fractions. That's a 35 over 3, x to the 2/3. And you're welcome to write this as 35, the cube root of x squared over 3. But let's not focus on the simplifying too much, just focus on the rule. All right, this next one, let's go ahead and rewrite this as 6 times x to the 1/2. So we're just going to bring that 1/2 down. So what's 1/2 times 6? Well, that's 3. And then I want to subtract 2 over 2. So what's 1/2 minus 2 over 2? Again, keep the denominators. 1 minus 2 is a -1. So it's going to be 3x to the -1/2. And if we want to take some time to put that in the best possible simplified form, that would be 3 over the square root of x. And we could certainly rationalize that, but we're not going to do that. The sum and difference rule is putting everything together, meaning, hey, if you see all these rules together with the plus sign, just attack each and every term. So for the first one, we have the constant multiple rule. So I'm going to bring that 6 here. 6 times -5 is a -30. X times, well, what's 6 minus 1? That's 5. This next one, 2x, well, we can think of that as 2x to the 1st. So I'm going to bring that 1 down. That's 2 times 1 is 2. And then we get x to the, subtract 1 there, x to the 0. And then what is the derivative of 6? Well, that is the constant rule, where we take the derivative of a constant, we always get 0. Let's go ahead and simplify this. What is x to the 0th power? Well, that's just 1. So really, our final answer is going to be a -30x to the 5th. And then this is going to be plus 2 times 1, which is 2. And then plus 0, we don't need to write. I highly recommend not doing this method with the x to the 0. I'd say let's start to memorize that any linear term is just going to have a derivative that is just the coefficient of x. And that makes sense, right? If I look at my function, y equals 2x, okay, that's y equals 2x there. What's the derivative, or what's the tangent line slope for that entire line? Well, here's a point. The tangent line would be right there, and of course that slope is going to be 2. All right, we will get a lot of practice with this. This is super important. Have a wonderful and joyous day.